All right, I see some people pouring in here. I want to welcome everyone to episode 1 of Dispatches from the Energy Transition. Today we're going to be speaking with TCC, Tanana Chiefs Conference, as well as Xendee to talk about some microgrid feasibility studies and the transformative power of microgrids. I'm one of your co-hosts today. My name is Lucas Miller. I'm a senior engineering consultant at Mayfield Renewables. Mayfield is a technical consultancy providing strategic support for solar and energy storage projects and products. We do energy and engineering consulting for project developers and EPCs, as well as develop technical training curriculum on solar, energy storage, and codes and standards. And with that, I'll toss it to my co-host, Robert Cross.
Thank you, Lucas. I'm Robert Cross, the principal of Outfit. We are a clean tech marketing agency. We focus on technical marketing, which we often do in collaboration with Mayfield. Lucas and I specifically do a fair amount of this work together. Visual storytelling, and websites. We're pretty excited to be here today. The focus of Dispatches and the reason why we've started this new series, the energy transition from centralized generation to distributed energy resources, is happening fast. We want to keep you up to date and informed on new technologies and how they impact projects. So we're pretty excited to have everybody here today. And our guest speakers, I would like to introduce them both. Eddie Delamare is joining us from the Tanana Chiefs Conferences. He's a rural energy specialist. Eddie, welcome to Dispatches.
Hello. Hi, everyone. My name is Eddie Delamare, the Rural Energy Specialist for Tanana Chiefs Conference, and excited to be here and be the guest speaker on the series.
And we'll also be joined by Michael Stadler, the co-founder and CTO of Xendee. Mike, it's good to see you again. I think the last time I saw you was in San Diego. Where are you today?
San Diego.
There you go.
Good seeing you again. Yeah, thanks for the intro. Michael Stadler. I'm with Xendee. We are a software company out of San Diego, California, and we support our clients like Mayfield with micro design software, but also control software. But I think today we are mostly focusing on designing microgrids. Good being here. Thank you.
Thank you, Mike. So let's take a look at this project. Lucas, Mayfield Renewables worked on a microgrid feasibility study using the Xendee tool for the Tanana Chiefs Conference. Why don't you walk us through what happened here?
Sure. So as Michael and Eddie alluded to, Mayfield Renewables was contracted to work on this feasibility study project, working closely with the TCC group, and we provided feasibility studies for 8 microgrid systems, which you see appearing here on the Alaska map. 8 remote communities spread throughout Alaska. As you can imagine, that comes with a number of environmental and supply chain challenges, which I will pass it to Eddie to speak a bit more about. And what you'll see throughout this presentation is kind of the results of our collaboration on this project. So we used Xendee almost exclusively for a lot of the modeling. TCC we rely on for boots on the ground information about each of these sites and collecting data on their energy usage. And then even working with companies like Outfit to produce some high quality visuals, like we'll see throughout the presentation, to educate the community and also to be used in the feasibility study report to receive further grant funding for the project. But I'd love to turn it to you, Eddie, to maybe speak a bit more about what life in these communities is like, what the energy infrastructure is today, maybe a bit about why a microgrid seemed like the right solution.
Thank you very much, Lucas, for passing it off to me. So if you guys, for those who may be familiar with the state of Alaska, those who are not, you guys are probably aware that Alaska is is the largest state in terms of size. With that comes many challenges, as Lucas noted. So Tanana Chiefs Conference, we're a tribal consortium based out of Fairbanks, Alaska, which is in kind of smack dab in the center of this large state. Our tribal consortium spans the interior, which is 235,000 square miles. That is roughly the size of Texas, the second largest state in size. So it's quite a large area, but of the 42 tribal communities that we serve and support with their energy needs, over 90% of these communities are off the road system, meaning that you cannot drive to them. So they are incredibly remote. So we access, and I visit many of these communities primarily via small bush planes. So, and in the summertime, they are accessible via barges or other watercraft, small boats. So logistically, when it comes to their energy needs, these islanded microgrids, they are powered primarily off diesel power generation. So the loads on average in these communities vary between, in some of the smallest communities, like 10 kilowatts, and some of our larger communities, maybe a couple hundred kilowatts, like 300 to 400 kilowatts, but kind of on average, we see like 100 to 120 kW loads. So you have in each community, you'll have a couple critical infrastructure, which kind of in terms of energy, you'll have a small power plant. It's roughly 1,500 square feet in size, houses anywhere between 2 and 4 generators. You kind of see these same engines in a lot of semi trucks. So Caterpillar, John Deere, Detroit Diesel, kind of are the flavor for these generators. And kind of as we've been moving and supporting our tribes and seeing how we can get them away from the ever increasing cost that is with using diesel as your prime source of power, which historically prices have only risen, and supporting them to their goal of energy sovereignty, meaning, how can they provide power locally? So through alternative or renewable sources such as solar and battery. So we've been kind of exploring the different angles throughout the years and consulting with experts in the field, such as Mayfield, amongst other people, national labs as well. And due to kind of the strong solar resource that we have in the interior, it's kind of been and with the decreasing costs that solar has been seeing throughout the years, and similar trends with batteries, it's been really suitable for our kind of long-term energy goals in these communities. So what you see on this map ahead of you or in front of you is 8 communities. They're primarily along the Yukon River, one of the largest rivers in Alaska, and they all are generally the same size, similar with their loads are very similar. And the goal is to install solar and battery, large solar and battery installations in these communities that can be in the summer months, which we have large solar resource, to be kind of the prime solar or the prime energy source that can really displace hopefully up to 40% of the fuel, since we'll be trying to use that resource as much as possible during the summer months and even in the shoulder season, so like spring and fall, when there's still suitable light. So that's a broad overview. Yeah,
Eddie, I'm just kind of curious, like a follow-up question. A feasibility study is supposed to help determine what's possible, right? I'm kind of curious, as you worked through this process with Mayfield, what did you learn going into it and then kind of coming out of the feasibility study process? Because it's pretty involved.
Yeah, definitely. Like, and we had done a number of feasibility studies. Some of them are with the communities that are listed in front of you, like Nulato. But what Mayfield really helped us understand is, in a very simple manner, was like, what is the sizing that would be most optimal, like will produce the most optimized scenarios. So it was very, effective communication of what are our options. Because at the end of the day, we're trying to get steel in the ground and move from concept to, reality. And so this feasibility study really unlocked what are our possibilities, and I would say really accelerated that, and really ultimately what I didn't touch up on, I think it really gave the funding agency, the grants, granting officers at the Department of Energy, the confidence in us that we had really gone to the experts in this field for that feasibility study that helped unlock our, confidence on how to do the best approach for a hybrid system that would unlock this energy transition in these communities.
Yeah, and one thing that really stuck out to me about this project was just the difficulties of transporting liquid fuel to each of these communities and how that can vary community by community. So if you could maybe tell us a bit more about what that looks like on a maybe annual or whatever recurring basis for you guys. As I understand it, some communities are connected to the roadway. Others may ship in diesel by barge, and others even by plane. So if you could tell us a bit more about what does that look like for those communities?
Yeah, it's definitely a story for every community of how they get fuel there. As Lucas mentioned, it's primarily barge. That is the most cost-effective manner. So on these larger river boats, they're transporting fuel in the tens of thousands of gallons. And that is just done through the very short months or very short time frame between first weeks of June all the way to first weeks of September. However, some communities are not accessible via larger rivers. So even though most of our communities are along rivers, because that's how Native people traditionally reside, along rivers, because they're really the highways of the lands that we have here. But some communities are so remote. So as you see in this picture in front of you, they're so incredibly remote that they have to fly in fuel. And that is the most expensive way to get fuel over. So in some of our communities where they really buy a lot of bulk fuel and they have a suitable bulk fuel storage, the price per gallon that they're seeing is honestly not that off from what you would buy in the lower 48. So on average, some of our I don't want to say well-planned communities, but some communities see prices in the high $3 per gallon. But on the communities that have to fly in fuel, it ranges from anywhere from $6 to $15 a gallon. So it really ends up translating, it incredibly bumps up their price, the kilowatt per dollar, the amount to actually generate electricity can be 3 to 5 times the national average, of the, close to $1 per kW. So it's or kilowatt hour. So it ends up being that fuel comprises 50% or more of that price per kilowatt hour. And flying in fuel is incredibly, incredibly difficult. So this picture here is in Hughes, Alaska, which used to have to fly in fuel. And it was such a scary, story at times, because that community of Hughes, that runway is kind of bare minimum for that size of aircraft. So it's incredibly limited and challenging for those pilots to fly in to that community by itself. But additionally, as you guys probably can think of, the weather can be such a challenge that when they need fuel most in the winter months, when the electricity and heat demands are so high, it's often also when the weather is the worst. So there have been times where they cannot fly in fuel because the pilots just cannot do it safely. So they'll be, stuck in without fuel, and potentially it'll be a days long outages. So it's great to have local, battery storage, or, able to produce your own power. So that's the goal. And so that's what we are seeing solutions. And now that community of Hughes, where that DC-6, that large plane that transports fuel, they have a 120 kW solar array with the 250 kWh battery or energy storage system. And they're seeing thousands of gallons of fuel saved a year and tens of thousands of dollars saved, which is doesn't seem like a lot, but for a small microgrid, it is incredibly impactful.
It just out of curiosity, Eddie, and that money saved, in one regard, that's one benefit, right? But then that money also probably gets used elsewhere where it could be more impactful, I would imagine.
Totally. Yeah, I mean, every penny saved is a penny earned, and definitely these, like, a lot of communities are starting to, or have been understanding for a long time that, self-reliance is very important, and yes, funds that can be used in other areas, that's the overall goal. That's the mission. So use your funds wisely, because at the end of the day, if you're investing in local power versus, just diesel, which is burnt and ends up being an extra emission, that's better to invest in something that, has a, is a local source.
Eddie, I'm kind of just curious in a follow-up question, because when you were telling Ryan and I the story, a month or so ago, we were talking about this. Can you describe the impact on the communities as people better understand the energy transition? Are people understanding what's happening as we transition to clean energy? Or is that also part of the job that we have to do as an industry?
Well, I think inherently and intrinsically, the Alaskan Native people are some of the most self-reliant people out there in the planet. For tens of thousands of years, they have existed off the lands in a subsistence manner. So they are well understanding that, they must do what they need to provide their own needs, their own, essentials, whether that is energy, food, etc. So yeah, very much intrinsically, they understand they need to do what they need to do, what must be done to provide, power. But it just, maybe the description of these newer technologies, that's really where these feasibility studies have been incredibly pivotal to, unlock, and in a meaningful and simple and to the point way of describing, how are they going to do this? How are they going to go to this transition? So that's been incredibly helpful to have such a concise, clear way to describe how can we achieve this self-reliance in these challenging areas that they live in.
Thank you, Eddie. That's probably a good segue, Lucas, into the feasibility study.
Yeah, I agree. I think that's a great example, Eddie, of there's a lot of reasons to consider in installing a microgrid, right? Not only resiliency, but also saving money on your energy costs, especially in remote communities in Alaska, but even parts of the United States, energy costs are only going up. So yeah, maybe with that, let's pivot a bit and talk a bit about what a feasibility study is. Before that, though, Michael, I'd love to hear your definition of what is a microgrid. It's one of those things, if you ask 5 people, you might get 5 different answers, but how do you think of what a microgrid is?
Well, as you said, there are multiple definitions out there. The one that I learned over the years is that it's a kind of controllable asset, which you can control for your own benefit, but you're also for the benefit of the utility, and can also disconnect from the utility if there's a challenge in the system. So some don't have this disconnect in the definition, but at the end of the day, I think it should be able to disconnect from the wider utility and be standalone if it's needed.
Great. Yeah, that's exactly how we think of it too. If it has to have the ability to island, there's definitely some production sources involved, likely some storage sources as well. Which gets into our process. 4 steps here. I'll do just a general overview of all of them. This is a service we've been offering for a little over a year now, I want to say, and with great results. We honestly recommend that almost any project that integrates storage with another generation source go through this process if possible. Like we've all talked about so far, really the goal is just determining what are your constraints and then adjusting for them. And so it's a very iterative, very collaborative process, starting out with just understanding what your baseline is. So in some cases, we'll perform a full 1-month load study, measuring on-site loads, collecting that data. In other cases, if it's a site that has green button data, maybe they already have utility information we can pull from, we may be able to skip this, or we may do a site visit instead. But we're really just trying to understand what is the site as is, what are the loads, how is the facility or the community using its electricity, and then working in this purpose analysis with the system owner to fully understand what their goals are for the project, and more importantly, what their initial constraints are. So is there a budget? Is there a hard cap to what we can spend? What loads would you want to prioritize backing up if we're unable to back up all of them? How much land do you have available to install a PV array? All would be examples of those initial conversations we want to have with the client before we dig into the modeling.
Hey, Lucas, before you get into the modeling, we have a question that's kind of timely from
Sure.
Bernie Dalva. What technology does Mayfield use for the initial data collection?
We use a variety of, I think, Fluke Megger meters, CTs that we can install on site, again, if we need to. But in many cases, we'll have access to green button data. I think in this case, the local utility, it's an electric cooperative, was actually able to provide us with data going back into the 90s. And so we didn't have to go on site in this case, but in other cases, we don't have that data. And so we do need to go in and either install a meter ourselves or ship a meter out and have someone do it locally, and then collect data for roughly a month and get 15-minute interval data we can then plug into these models for step 2. And so when we get to this point, this is really where a lot of the iteration takes place. So we use Xendee first and foremost for a lot of this modeling. That's everything from energy modeling. So what are the loads? Where's the power going to be moving back and forth? What happens when we're disconnected from the grid? To financial modeling. Again, in this case, we're saving money by not using diesel. In other cases, maybe we're exporting for time of use. We're avoiding peak demand charges. And then thirdly, and this is something that might be unique to Mayfield, is we have our modeling engineers working with our design engineers. So throughout the process, we're using what we learned from the energy and financial models to build a preliminary design set. So we call that roughly a 30% set, something you could take to your grant application or even to a utility just to have them better understand, here's the goal for the system. It's not 100% ready to go, but based on our modeling and analysis, this is what we think is feasible, and these are the products we suggest for the project.
I think something that's very interesting about this, Lucas and Mike, you and I talked about this a bit in San Diego. You can kind of see it on this chart. There can be a fair amount of tension between the energy modeling and the financial modeling, right? and how do you get to that proper design? Can you just give a little bit of feedback about the balance between meeting those goals and how it can impact the design?
Lucas, you want to do it first because you did the modeling, so.
Sure. I mean, there's surprises on both sides, right? I mean, we understand, we have a better picture of what's possible here. So in some cases, that means, you know, like maybe this is actually a good example of a project like that, where in the northern latitudes, your row spacing for PV rows is much further apart than it would be in the lower 48. And so what we had to bake into these models was, I think, 70-foot row spacing, which means our array is now basically much smaller. What we can build in a certain square footage area is smaller than what it would be in like South Carolina, for example. On the flip side, though, through the energy modeling, we can look at different scenarios and say, well, what if you purchased this plot of land, or we upsized the battery by X amount? And then this is what's achievable under those scenarios. And depending on who your system owner is, maybe that's justification to increase the budget just to see, hey, we could speed up our ROI by 2 years, 3 years, or save X number of dollars. So it definitely goes both ways. I mean, it can constrain you a bit more, or it gives you more options. But the real goal is that at the end, everyone's clear-eyed about what is possible and the reasons why we're doing what we're doing. But anything to add there, Michael?
Well, I have a different, I mean, I will offer a different perspective on this, because from Xendee's perspective, we see this a little bit integrated here. So energy modeling, preliminary design, and financial modeling is all part of one run. And you can, as you described, you can define certain input scenarios and you do scenarios around this. So from a modeling perspective, yes, you do energy modeling, you have to preliminary design the financial modeling, but from a Xendee perspective, they're actually integrated, and you can solve this in one shot if you have the right input data. And I think that's what you meant on and did when you said, well, you do the spacing, you put it in, and then you do this, because the financial modeling, it's a constraint, right? I mean, as you know, you can add different financial constraints, and then it will solve the system with the different energy constraints and financial modeling constraint to get an optimal design for these constraints. So yes, these are different things to think about, but from a modeling perspective, in Xendee, they are really linked and solved in one shot.
Great. Yeah, so this is where a lot of the dirty work happens, really. There's a lot of modeling, iterating, redoing, shuffling some things around. And then we get to stage 3, which is where we present our initial findings to the site owner. We review all the models we have built. We talk about what assumptions were made. And this is where we get most of our initial feedback from the client. So maybe we present 2 or 3 options that are available, or we say, based on your constraints, this is what we think the best path forward is. Once we all agree on what that path looks like, then we pull together a report that is, in our case, highly detailed, but it's meant to also be concise, kind of used for information sharing, used for grant applications or interconnection applications. And we share that with the end client as well as that 30% side.
And we have another question, and I'm not entirely sure relative to this project. Maybe Eddie or Lucas can kind of speak to this. And I'm not going to be able to say this gentleman's name properly, but Furbad is asking, for a project like this, approximately how much percentage or price of the costs were allocated to the feasibility study. My general understanding, because I just wrote an article on this, that the cost of the feasibility study is typically 1 to 3% of the project cost. It's lower than what people think. I don't know how much it was in this particular instance, or if anybody's aware of that, but we can kind of follow up in more detail. Eddie or Lucas, do you guys know? that specifically, not offhand.
I don't have that figure.
Yeah,
Well,
for us,
go ahead.
for
No,
costs,
go ahead.
like, I mean, we hadn't, so for this specific project, we hadn't gotten funding for these 8 villages for their solar batteries system yet. So we kind of have a general fund that we use for grant writing and for feasibility studies. So we just have a kind of set aside fund for that specifically. And yeah, to kind of answer one of the other questions, I mean, due to the fact that we have an existing relationship, it kind of just paired well of utilizing Mayfield's, you know, additional strengths, which are these feasibility studies.
So one thing to add here, because I think, Robert, you're very much there with 1 to 3%. We did 2 years ago, we did a study with the Department of Defense to actually compare how much time it takes and costs to use Xendee, a standardized approach, compared to others. And we got in that range of 1%. Actually, we were around more than 1%. And I think that's the thing, because you want to standardize this process, right? And it's from the data collection, it's how you model things, how you do sensitivity runs. So if you standardize this and know where to get this data, you can save actually a lot of money actually here.
I'm probably a little bit biased because my day job is as a consultant. But from my vantage point, it's not just about upfront cost and how it relates to the project, but you're trying to mitigate risk. It better informs installation. It better informs design and construction considerations, and then O&M after the fact. And so generally speaking, to me, it's not when we try to do a feasibility study or a process of this ilk, I don't think people should just be thinking about the upfront cost, but the benefits after the fact, including during the process.
Yeah, and if I can add maybe just a bit more on, you know, what does that final delivery look like? Like we hand off a comprehensive report that is meant to collate all the information we've gleaned in steps 1 through 3 and package it in a way that a decision maker could read through it and understand what we're talking about and why they would want to move forward. And so that could be a developer deciding let's pursue this project or not, or that same report could be used for a grant application to receive more funding to actually build the project. So we're trying to share our information in a way that's easily accessible and understandable for folks, but really package a ton of detailed findings together that we can hand off to a client and they could use it any number of ways to keep the project moving.
It's great, Lucas. We should probably keep moving.
Yeah, maybe this is a good point to hand it off to Michael. You want to tell us a bit more about the Xendee platform, Michael?
Yep. So I was already touching on this a little bit about standardization, right? And I mean, you at Mayfield, I mean, you standardize also more stuff, not only for modeling, but we standardize the whole process from screening to operation of microgrids and distributed energy resources. We use the same technology in the background. And in this project with Mayfield, you guys were using Design, which is our most mature product, which really does techno-economic design. You can also do power flow, distributed system modeling, and all these things. But with Discover and Propose, you could screen systems. Like say Discover, you have 100 different sites, and you want to figure out which one is best. You could do this in an API-based approach. And Propose is really for proposal writing if you want to offer as a vendor a technology to a client or to the government, you could use this. And then there's Operate, which actually controls these technologies in the field, uses the same technology, just real-time information. And for Operate, we see up to 80% cost reduction actually if you put in such a software-based controller compared to existing rule-based controllers. But key is you want to design a system which gets very close to reality. And this is our hypothesis here. What you do in design or propose or discover should be reflected in Operate, because if you design something which then gets run in a completely different way, you're probably losing money. I mean, I guarantee you're losing money, and you're not making people happy. So these steps need to be linked, and this is a value proposition actually here.
Mike, just to take it a step back a bit, what problem is Xendee trying to solve? And when you answer that question, I mean, we're looking at, in this instance with TCC, a series of microgrids, but then you start thinking about scale, and you start thinking about the energy transition and the pace of it. What problem is Xendee solving?
We really want to enable our clients to do projects at scale. Because if you're serious about the projects that we're talking today, it cannot take years to actually design them and implement them. So you need a standardized process from the beginning to end to be way faster. So that's our underlying promise here. And we already reduced the design times by 90%. I mean, based on what I hear from Mayfield, I mean, it's pretty straightforward. And we want to do this also for operate. So from a scalability issue, it's really being fast and credible so that we can execute on the hundreds of thousands of projects that we probably have to do in this space.
And Lucas, I know that Zach, your coworker, does a lot of these at Mayfield, but you've been kind of peering into it in recent months. Can you talk a little bit about, from Mayfield's perspective, focusing on more complex design work and modeling work at this point, and the impact of working with some?
Sure. I mean, I think we made a conscious decision a couple of years ago to really just start pursuing projects that integrate storage, and especially what we call middle market. So not residential, not your 100+ megawatt utility scale, but kind of everything in between. You know, the industry is awash with companies that can offer you a residential plan set fairly quickly for a grid-tied PV system. But to understand how, especially microgrids, but any systems with storage will work and be programmed, takes another level of expertise. And so we kind of saw that as a hole in the industry and somewhere where we could fit in. And so that's where most of our engineering energy is focused these days. Around the time that we made that decision, we asked around, like, what modeling programs is the industry using? What are subject matter experts preferring to use? And from that research, Xendee popped up over and over again. And one of the contractors we work most closely with said he almost exclusively used Xendee for this type of work. And so we've spent really the last year, maybe 18 months, really getting to know the platform and getting more comfortable with it. I am not a super user myself, but from what I hear from our team, a big part of why we moved to Xendee was it's very intuitive and easy to use. A lot of other platforms can be clunky, but Xendee simplifies it, and it's also very flexible. It's easy for us to pull in a synthetic load profile, for example, or build our own in the platform, or use green button data. It's just, it does everything we need it to, and it's not overly cumbersome to use. So many reasons to check out the platform.
I think obviously I work with both companies, both Mayfield and Xendee, but a key aspect of the energy transition is it's happening in real time. And I think part of the value, if you're a project developer or a city that's considering microgrids, it is a complex project. And I think it's pretty important that the companies that you work with do take a consultative approach. We're all trying to learn together. It's not easy work either. Lucas, maybe go to the next slide for Mike.
Yeah, I mean, the point is that we can model very distributed systems. You can consider also the heat flows, the power flows between those different nodes. So this is an example from military side overseas, which we completely designed from ground up. Energy flows, electricity flows, and all those things. So I think Mayfield, with the feasibility study, didn't get into these details, but this is exactly my point from early on. You do a feasibility, and then you can move it into the next stage if you want to do this, if you have a more complicated project, and also see what the impact on the distribution system is if you want to do this. But I think that's all we have to talk about, Xendee. So let's move on.
Mike, the one comment that I would make that's pretty important, again, that we've talked about here and there over time, in order for this to work, to move forward, because it is a complex work, the tool and the platform needs to be easy to use. Can you talk a little bit about how the platform was designed and how ease of use leads to projects being built, right?
Yeah. I mean, what you're looking at now is work of 20 years. So before actually we founded Xendee, I started this in 2001. So we're actually looking at 23 years of work on the back engine. And it was as it was still with the national lab system. And it was, I mean, you needed a PhD to run this, but we realized that we have to simplify this. And this is why we started the company, to really add these interfaces to make it simpler to use, because that's the only way how you can transform the market. So there's a lot of knowledge going into this. We did more than 200 journal papers. It got reviewed, I mean, by companies. We benchmarked it against manual methodologies and everything. But at the end of the day, it was a 20-year process to get to this point.
Thank you.
Well, with that, maybe let's start closing out here by looking at what the project actually will look like in this case. And so we've got a quick kind of animation on screen here. I'm just going to pause it throughout a few moments. So what we're looking at is just a very simplified, almost like a single line diagram of the proposed sites. There are 8 remote communities involved in the project. So this is by no means precisely what we're installing, but a generalization of across all 8 communities. They had a similar electrical makeup. So in all cases, there wasn't an existing utility grid as we think of it to tie into. So oftentimes the microgrids that we'll see in the lower 48 are in some way connected to the broader grid and just have the ability to disconnect through a contactor automatic transfer switch. In this instance, we're really adding to an existing grid and making it more resilient. And so, as Eddie mentioned earlier, in each of these communities, they're reliant on diesel generators, centrally located, with fairly traditional power lines operating at medium voltage to carry the power from the generators to the communities. What we're planning to add is a centralized switchgear next to the generators with on-site energy storage, and then remote PV arrays. So again, given the land constraints and geography, it made more sense to co-locate the batteries with the generators. So I have kind of a central power hub with the switchgear acting as the brains of the operation. And then the PV arrays in many of these communities are a bit more isolated in plots of land that were open or have good solar exposure. So we'll be connecting the PV array to our switchgear through those medium voltage power lines as well, with everything tying together in that same generator house that already existed. So again, just a oversimplification, but just a quick picture kind of where we started from and what's planned to be added. Am I missing anything key there, Eddie? Anything else you want to add?
No, I think you did a great job at describing these systems.
I think part of the value of the feasibility study process is to educate and inform throughout. And we use 2D diagrams, animations, videos, different ways to convey information. There are a lot of complex topics, and we're all trying to learn it at the same time. I sometimes think, and working with manufacturers and different service providers, visual tools can help a lot to explain complex technologies and things that are happening.
Great. Well, I think we've got maybe one more slide here. Eddie, I'm going to turn it to you and really just looking ahead to the future. So we've kind of given an overview of what the project is, but if you could speak a bit about, potential impacts of the communities and what's next for TCC.
Yeah, so kind of like post, because last summer, this is when we conducted these feasibility studies with Mayfield support with these tools mentioned, like Xendee. And so earlier this year, it was announced in February at one of these conferences in California that TCC, Tanana Chiefs Conference, was selected as one of the awardees. And so we've just been actively in the initial stages of this grant for $26 million plus. And so we've been working adamantly on that, on these initial stages, now following up and moving, trying to, gain the momentum again for engineering to get issued for construction design. So that's kind of been the world post feasibility for us. But, just to talk more about these project results, we're 100% trying to work towards stabilizing these electricity prices, and really these high costs of fuel. That is our way of stabilizing the costs. And if we, effectively install these systems, what these optimized feasibility studies have given us, we think that, we'll 100% be able to stabilize prices, and we'll be able to work towards actually lowering the costs. Because at the end of the day, the customers, the ratepayers in these small communities are kind of put in this burdensome position where they're paying hundreds of dollars per month. And, it's definitely a difficult position to be in when there's a community of 60 people paying 3 to 5 times the national price of, electricity. And, in some of the poorest communities in America. So this is a huge sigh of relief to see that there's these optimized systems going to be installed to really tackle that big issue of liquid fuel diesel, which is, only increasing in price. So being able to stabilize that is pivotal. And it kind of like, two birds, one stone scenario, the greenhouse gas emissions are 100%, improving. We were doing some study with EPA earlier this year, and it's pretty interesting to know, and I don't have the exact metric or figure in front of me, but per capita, the emissions in some of these local communities, the emissions are quite high for some of these pollutants, carbon dioxide, and other co-pollutants, due to the fact that these small engines that are running 24 hours a day, 365 days of the year, they burn a little less clean than, say, your larger natural gas power plants that burn, that are working a bit more efficiently. So lessening the greenhouse gas emissions is also quite a huge feat that we're hoping to achieve. So everything, we're just incredibly grateful for the support that Mayfield and all these tools have provided.
Eddie, I have another question that has more to do with O&M from Gene Kraswinski. How do you handle the remote nature of these systems? I mean, I imagine that's part of your work, the O&M and spare parts and things of that ilk.
Yeah, certainly. So, Alaska has a population under 1 million people total. So these communities have very small communities sizes. The population is quite small, therefore the workforce is quite small. But it's definitely within our goal is to, during the early stages of these projects to really familiarize community members, some of the key utility workers on trainings and, so that they become local leaders in this energy transition. So we're using a lot of, one of our largest goals is also to be encouraging workforce development. So in the early construction phase of these projects, like the solar installation, we're having our preference is Alaska native hire. So local is always best. That way people can start to understand these systems intrinsically, work with the contractors, and, therefore, once it turns over to the community's hands, they already have a knowledge of the system, and we'll be working along, through the creation of an independent power producer to ensure that, these systems are sustainably funded in order to ensure that there's funding and resources to ensure that people can sustain with, sustain these equipment. So that's kind of the model that we're presenting, is just, from the beginning till, the lifespan of these systems, 25 plus years, is ensuring that there's resources available.
Eddie, I think you touch on something that I think is worth speaking about. And Mike, I believe you have a perspective on this. When we think about the distinction between centralized generation of energy and distributed energy resources, I think there's a clear economic benefit, economic distinction for local communities that are focused on distributed energy resources. Would you like to touch on that a bit from your perspective, Mike?
I mean, since we're in the business of doing distributed energy resources, right? I mean, the answer is yes. And it has to do with the fact that in a microgrid, most of the time we think about electricity, but there's heating, there's cooling. And if you have CHP systems, if you have fuel cells maybe in the future, you can really increase the system efficiency a lot. So that's one thing. The other thing is, I mean, if you're in areas where you have a constrained distribution system, running microgrids in a way which lowers the burden on the distribution system will also reduce the societal costs, right? Because, I mean, why upgrading the systems for the peak if you can manage it differently? So yes, I see a lot of value in this distributed energy resources if planned in the correct way and also managed in the correct way. I'm not saying that we will get rid of centralized systems, but the question becomes, do we want to upgrade them at really high costs to just cover peak events, or do we have smarter ways of doing this? And I think it's clear that we want to support more DRs here.
Thank you, Mike. I'm biased. Part of it's also the study of economics. I think that at the end of the day, localized resources are better deployed from my individual perspective. And a lot of this work, due to its complexity, is not possible without a feasibility study and modern tools. And I think that that's in part why we're here today.
Yep.
I know we've got just a few minutes left here. Anyone in the audience is welcome to submit more questions in the Q&A. We did get one. Eddie, I see you typing out an answer to it, but I'm going to ask here as well, because I'm curious. There are certain limitations on transporting lithium batteries in particular. So in the instance that we're installing these systems, let's say, what challenges do you foresee with transporting batteries and installing them in these communities?
Yeah, there's some pretty unique scenarios with the smaller outfits, the smaller transportation resources that we use. So for instance, the company Everett's Air Cargo, they're one of the larger air services that provides freight over to these communities. So if we're in this scenario that we need to fly batteries over to some of these communities, we unfortunately have to take a bit of that onto the budget and say, well, and since we're entirely grant funded for installing the systems, for the less, we only actually face a handful of communities that are only fly-in. So that just results in, a couple $100 per kilowatt extra for these battery systems that we're planning on installing. So we have to kind of piecemeal for some of these limitations. We don't see that small of weight limit restrictions. We don't have that 35 kilogram weight limit restrictions for lithium ion batteries cells. We're able, I believe, the only data point that I can draw on is we had a roughly 200 kWh system using Blue Planet's containerized battery system, and we just had to transport the DC blocks individually, and we kind of just had to do it kind of piecemeal, but the preference, and how I summarize it, the preferences for the majority of our communities will avoid doing flying in cells. We'll barge in, so watercraft or driving it over when possible, but primarily on barges. That's how we'll transport these cells.
Okay, thank you, Eddie. I'm just going to answer one more question, and then Lucas and I will follow up with a lot of these in post-production. Kelly Larson asks, what microgrid education resources can you recommend for engineers and users? It's kind of somewhat of an obvious answer. Mayfield puts out a lot of education and content, online workshops, technical articles. I think we have a technical article coming out on microgrid feasibility studies later this week. That's one way to keep abreast of things. But, thank you.
All right, you want to close this out, then, Robert?
Sure. We're happy for everyone to join us. It's been great putting this together, and I really appreciate, Eddie, your time, and Mike, your time to come on today. If you guys want to talk about how you might be reached, you're welcome to do so.
I think there's my email address. So if someone wants to follow up, just send me an email or look me up on LinkedIn. I'm happy to answer more questions and help out.
Same. I'm also happy to answer any questions. And if there's anyone here that is, just putting a plug out here, that is looking for work in some of our, we are hiring a project manager. So we're happy to entertain that as well. So we're always looking for extra help, and anyone that is a rock star that wants to move up to Alaska and work on some of these microgrid projects.
Also, Lucas and I want to thank Chris Cow of Solar Builder. They too are a partner on dispatches from the energy transition. There's going to be more from them shortly. And the future episode, we're still putting this together, but we plan on having Tom McCalmont. He's the CEO of Paired Power. It's a very interesting microgrid solution for EV charging. And Jonathan Rogers, the Director of Mobility and Energy Transition for the City of County of Denver. Our second episode is planned on focusing on smart solutions to propel EV mobility forward. There's a lot going on in that aspect of our space too. Want to close, Lucas? Anything else?
That's all I have. I would encourage everyone on the call to research grant funding opportunities for these types of projects. There's more out there than you'd expect. Oftentimes people coming to us for support on these projects are grant funded. So I would highly recommend researching what's in your area and what's upcoming. But with that, I think we're at the top of the hour. So just want to thank everyone again for attending. And
thanks for having us.
Yeah, thanks, Michael. Thanks, Eddie. Thanks, Robert. And
Thank you all so
we'll
much.
hope to see everyone next month. But
Yep.
thank you.
Thank you.